powerful because they're visual reflections of some type of action. And often by looking at things, we actually gain tremendous insight. Look at this question, for example. Suppose an empty bathtub is filled with water from a high-pressure faucet until the level is half the tub's height. A person gets into the tub and after a few minutes gets out and releases the drain, and the water slowly drains. Question is, how can we visualize that in terms of a graph? I'm going to show you three possibilities, and let's see if we can think about which one more closely reflects the action. So here are three graphs. Let's just take a look and notice that on this axis, we're graphing time as time moves forward. And on this axis, we're showing the amount of water in the tub. So let's just think about this, for example. In this graph, what we see here is that as time goes on, at the beginning, the amount of water in the tub increases. Well, that's good. We're filling up the tub halfway. And then it plateaus off. So that means that at this point, as time goes on, there's no change in the water. And then what happens here? Well, the water level starts to drop. So in this graph, we see that the water is added to the tub for a while, then it's turned off, and time goes by, and the water level stays the same, and then the water is let out. Is that the scenario we have here? Well, let's take a look and see if that really is reflected. Let's take a look at this one. Time, water. Here the water is put into the tub for a while, and then all of a sudden there's this really big spike. Can you think about why all of a sudden the water level would jump up? Well, remember that at one point a person actually gets in the tub. When that person gets into the tub, that's going to displace the water level up quite a bit. So now we can actually see the person getting into the tub. And then that person stays in the tub for a little while, so there's no change in the water level. And then the person gets out of the tub, big drop in the water level, and then the water level decreases as it drains. So that actually looks more realistic than this. Now we realize that the person never actually entered the tub on this one. So this one now is out. Now, what about this one? Well, this looks very similar to this. The water level increases, the person gets in the tub, stays in the tub for a while, then the person gets out of the tub, we have a decrease in water level, and then the water is drained. So now we have to figure out which of these two more accurately reflects the situation. Now, if you look at these, you might say, boy, these look the same. Well, there's a slight difference. Notice that in this first graph, it takes a lot longer for the water to get to this point. Whereas here, the water gets to that point in a much shorter amount of time. Look at the difference in intervals. So is the water being added fast or slow? Let's go back to the question and see. It says that it's being added from a high-pressure faucet. That means the water's coming in really fast. That means we get a lot of water in a short period of time. So this more accurately reflects that situation. We see that a lot of water is added in a little bit of time. Let's just check that with the tail part. What do we know about the tail part? When the water is draining, it's draining slowly. That means it should take a long time for the water to drain out. And notice that here, this is draining out fairly quickly, and this is draining out in a much longer period of time. So when you analyze all that stuff together, you see that, well, this we can throw away quickly because the person never entered the tub. And these two are a little bit more tricky, but we see here the water is let in fairly slowly. Person jumps in, comes out, and the water is let out fairly quickly. That's not quite reflecting the situation, and this one is. So notice that a picture, a graph, can really allow us to express what we're seeing in a visual form.